Hi, in this tutorial I will give an overview of RFID, or short for Radio Frequency Identification System. So the content of this tutorial is to give a short introduction to RFID, what RFID is, what you can use it for, and the main components in such a system. I will give a short overview of different RFID readers. I will focus on two in this tutorial: a Parallax USB RFID reader and XL MyCode USB RFID reader. For both these readers I will provide examples both in Python, in LabVIEW and in Visual Studio C#. So RFID is an abbreviation for Radio Frequency Identification System. So basically it's a system for identification different types of items. You can use it for access control, inventory control, etc. So RFID uses wireless communication that transfer data between the so-called tags and the RFID reader and the RFID antenna. We have different types of RFID systems that uses different types of frequencies. We have low frequency, high frequency and ultra high frequency. And we also have different types of tags. We have active tags and we have passive tags. So passive tags are the most common. They are powered by the energy of the RFID reader itself, while active tags have a separate battery included. So here you see a short overview of the components that are part of an RFID system. You have the tags. They come in many different flavors like cards and different types of items. And this has this built-in RFID system that are communicating with an RFID reader, and also typically in an RFID reader you have a built-in RFID antenna that pick up the signals from the different tags. And typically this RFID reader is a microcontroller, so you typically and those comes typically with a USB connector that you plug into your computer. Mostly the RFID antenna is built into the microcontroller, but you can also have a separate or an external antenna for better range. So typically you connect the RFID reader. In this case there's a built-in RFID antenna that pick up the signals from the different tags, and then you can connect it to your PC using a USB cable. And then you need to create a program in a programming language like Python, LabVIEW, C#, etc. So I will provide examples in Python, LabVIEW and in C# later. So as I mentioned, we have different frequencies. We have low frequency, typically 125 kilohertz. The range for this system typically 20 centimeter between the reader and the tags, and the tags are typically read only. This means that you can only read information that are stored in the tag. You cannot write information to the tag. This system is suitable for application with a short distance, typically access control, attendance control, electronic billing, electronic wallet, etc. And then we have high frequency, typically 13.56 megahertz, and the range here between the tags and the reader can be up to 1 meter. Here we have both read and write tags. And finally we have this ultra high frequency that uses a frequency 433 or higher. And ultra high frequency systems can have a range up to 100 meters. And also here you have read and write. Here you can also read and write information from the tags. Now I will introduce two different RFID reader systems. I will start with a system from Parallax. So here you see an overview of this system. Here you see the RFID reader with a built-in antenna, and this is a 125 kilohertz RFID system. So you need this reader with the built-in antenna, and then you have this USB connector here that you can connect to your computer, and then you can have different RFID tags that you need to put close to the antenna in order to make it work. So before you start, you should always start reading the documentation from the vendor. So here are some important information from the documentation. So this Parallax USB RFID reader is a 125 kilohertz RFID system. You just plug it into your computer, and then typically automatically the FTDI driver will be installed automatically. You need this driver in order to communicate with the device from your computer using the USB cable. This system has a short reading distance, so you need to put the tags no more than 10 centimeter from the reader and the built-in antenna of the system. So most RFID readers are based on serial communication, and the serial communication are through this USB cable and this virtual COM port driver, as mentioned earlier. So this FTDI driver that handle the serial communication through the USB system or the USB cable. For this system, it uses a 8 data bit, no parity, 1 stop bit, and a 2400 bits per second. So this is information that you need to set when you are going to communicate with this device, either from a serial monitor or if you program it using a programming language like Python, LabVIEW, C#, etc. And this particular system generates, so each tag has a unique ID, and here these tags has a 12-byte ASCII string that you can read in either of these programming languages or in a serial monitor software. So next I will go through some code examples. First I will show example in Python, and I will show in LabVIEW, and then finally in Visual Studio and in C#. So here is the system I have at my desk. So here is the USB RFID reader with a built-in antenna. I have connected a USB cable that I connect to my computer. I have different tags, and each of these tags has a unique ID, which you see here. So I just labeled them with the unique ID, so when I create these programs I can see if they generate the correct tag or not when I tap these tags on the reader. So the first thing you need to do when you plug in this device into your USB port on your computer, you need to open the device manager. So just go to the Windows Start and find the device manager, and then under ports here you are able to see if the device is connected properly. So here in this case the RFID reader is connected to port number COM4, and also can right click here to see if everything is okay and the device is working properly. And you see this FTDI driver has been installed properly. So now this device should be ready to use. So let's open Python and see if we are able to retrieve the tags from this system. So now I have made this Python script. I'm using, in this case, the Tony Python editor, but you can of course use any kind of Python editor. I need to import the serial library and the time library, and then I need to start the communication with the serial port using serial.serial, name of the COM port, in this case COM4, 2400 bits per second, says the protocol in this for this system. And then inside a while loop, I just read continuously from the serial port. And then if I'm able to read 12 bytes in this case, I just print the response from the serial port to the shell here in my Python editor, and then I sleep for 1 second, and then this while loop go into a loop forever. So let's just start this program. I just in Tony you can just click this run script button or F5. So now you see here in the bottom it's just reading an empty string, but now let's put one of my tags on top of the reader. So you see I'm able to read the tag ID here. So this is the unique tag number for a specific tag. Then I remove it. I find oh no, I stopped it. So let's start once more. So now I put another tag to the system. I remove it. Put a new tag on the system, etc. So you see this small program are able to read the tag from the serial monitor. So I just tap the different tags on top of the reader, and you see that I'm able to read different types of tags. So basically, in order to make this work in Python, I just need to make this small program in order to make it work. Of course, this is just to demonstrate the principle for reading tags, where you tap the tag on top of the reader, and then you are able to read the unique tag ID into the Python environment like this. So next, here you see an example created in LabVIEW. So here you see the graphical user interface or the front panel. So here I will present the RFID tag from the system, and let's see the code or the block diagram. So here you see the block diagram. I start the communication with the serial port. I select the COM4, the baud rate, which is 2400 bits per second. Data bits is 8, and parity is none according to the information in the datasheet. So this opens the communication with the serial port. Here I read bytes that comes from the serial port, and when I read 12 bytes, I go into this true case, and then I find the RFID tag, which I present here in the front panel. And then when I click the stop button, the program will stop, the while loop will end, and it will clear and close the serial port. So let's just run this application. I go to Window, click on the Run button, and then I take one of my tag, put it on top of the reader, and then you see I get this unique tag ID, and now I put another tag. So you see the unique tag number. I remove it, I put a new tag on top, and you see I get this unique tag ID from my different RFID tags. So basically, this is a very simple LabVIEW program that are able to communicate with the serial port and read the different RFID tags like this. Next, I have created a very basic example using Visual Studio and the C# programming language. So this is an ordinary desktop application, a WinForm application with one form. So I have the form here. I just double click on it and open the user interface. So here I have a text box where I'm going to present the RFID tag that I tap on the reader. This is just a label. I have two buttons, one for initialize the serial port and one for read the tag ID, which I present here in the text box. Of course, this application is just an example. Of course, you should put this into a while loop, a timer, etc. that read the tag continuously, and then you can check the information and communicate with an SQL Server database, etc. to create a real RFID system. But let's just start this basic example, clicking the start button. So this is the graphical user interface. I start by initialize the serial port, and then I can tap a tag on top of the reader and click the read tag, and then you see the RFID, unique RFID tag are presented here in the text box. So now I click initialize once more, and then I tap a new tag, and it's presented here in the text field. I do it once more, initialize the serial port, tap a new tag, and then click read tag, and then you see I get a unique RFID tag here in the text box. So let's just close the application and see the code for this system. So the code is based on, I just open it, initialize, and the C# code for this one. So I just start to open the communication with the serial port using this line of code, using the built-in, so I need to use this namespace system.io.ports. So then in this namespace you have this method called serial port. You define the port COM4, the data rate, parity none, 8 data bits, and a stop bit, yes, like this. Then here I just initialize the serial port with the information from the datasheet for this system. And then when I click the initialize button, which you find here, I open the port and enable this BTR, which need to be enabled, and then this text field, I just clear it so it's ready. And then when I initialize the serial port, I can click this read tag when I tap a tag above the reader, and here you see the code for this read tag button. So I just create a variable called number of bytes to read is 12 in this case. I define a byte array, set a read timeout of 1000 milliseconds, and then I start reading from the serial port. And then the data I get, I just encode it to a UTF-8 format, and also then I remove the start letter and the end letter of the tag, and then I just present the final RFID tag and put it into this text box. And finally I just close the port like this. So basically that's the entire program in order to communicate with the RFID system. So here you see the next system I want to demonstrate in this tutorial. This is a USB RFID reader from Excel. It's called my code USB RFID reader. It looks like this. It comes in different flavors. This one has a USB connector. It has a built-in antenna. It's very similar to the previous device, but this system using this is a high frequency system using a 13.56 megahertz frequency. So I have this device. I have different RFID tags which I will use to demonstrate this system. So basically you connect this device to your computer using a USB cable as the previous system. You open the device manager to find the COM port that is allocated for this system, and you can use the device manager to see if the device is installed properly. Make sure that this serial USB driver called FTDI is installed properly. And of course go to the vendor's homepage to download the datasheet and read information about the system. For this system you can also install a test software called Micro Rfid MFIC, which you find on the web page. So you can go to the vendor's web page and download this test software. And also here you find the necessary information and the necessary data sheets that you need to read properly before you start using the system. And you have installed the test system, plugged in the device into the USB port and make sure it's ready to use. Read the datasheet, then you are ready to start creating an application in a programming language that can read tags from this system. So here you see the device manager. So I find my device under ports here, and in this case it has been allocated port number COM3, so I need to use that information when I create my applications. Also see that this FTDI driver has been installed properly, and also you find from the datasheet that this system uses 9600 baud rate, 8 bits, 1 stop bit, and no parity. So this information is found in the datasheet from this system. And here you see the test software that you can install and configure the RFID system. So typically, and for this system, make sure it's connected depending on what kind of tags you are using. In my case, I'm using a MeFair 1K classic tag. So I click on this one, and then this pops up. And then when I tap the tag on top of the reader, I'm able to read the unique tag ID here. You can also use this software to configure different parameters. And also this system is more advanced than the previous system. Here you can also both read and write information to the different tags. And also, in order to make this system work with your computer and a USB cable, you also need to set some configuration. You find information about it in the datasheet. But basically, you need to open this test or configuration software as shown here. So you need to select this one if you're using a classic 1K MyFair tag. And then this pops up if you select RVD parameters. And then for parameter number knee, just select this one and write to micro RVD here. And then this window pops up. And from the datasheet, you need to set this parameter to 01 like this, in order to be able to read the unique RFID tag using the USB cable. So just enter this value, click on write, and then you are ready to use this system. Next, when you have configured the device properly, it's also a good idea to use a program or a software for debugging the serial communication. There exist lots of different software for this purpose. One software is called RealTerm. So RealTerm is a tool for capturing, entering and debugging the serial communication between this RFID device and your computer. You can download this RealTerm from this web page. And of course you need to use this software in combination with the datasheet in order to learn more about the communication protocol that are used for this device. So this is RealTerm. Another software is called that you can use, which has similar features like this RealTerm, is called YAT. So that's just another program that you can use. This YAT program has the same feature as RealTerm, but the user interface is more modern. A third program is called HTerm, which is very simple to use. You can also download it from this location, and then you can use these either RealTerm, YAT, HTerm or another program in order to make sure that the communication between the device and the computer are working as expected. So here you see I use this HTerm software in order to check my device. So I just need to select the proper port, proper baud rate, 8 data bits, stop bit, and no parity. And then turn on this CTS flow control and then connect. And then you are able to communicate with the device. So if you enter here set, then you are able to read information about this RFID reader. So by using that you can find out that this device is working properly. So the information read back from the system says the name of the device, etc. Next, you can use this HTerm or a similar program in order to retrieve the unique RFID tags. So just tap the tag on top of the RFID reader, and then you should be able to read the tag unique tag ID based on or using this HTerm system. In this case it's in a hexadecimal form, so I just select hex here in order to retrieve the unique tag identificator as a hexadecimal number like this. So now that we know that the reader and the tags are working properly, now we are able to start creating some code. So let's go to the code examples. So here you see an overview of the system I have on my desk. I have this RFID reader with a built-in antenna, a USB connector that I connect to the computer using a USB AB cable. I also have a case which I put the reader inside this case to make it more robust. And then we have two LEDs, one red and green. So when I tap a tag which you find here, I have different 13.56 megahertz RFID tags that I just tap on top of the case when I have the reader inside, and then this turns green to indicate that I'm using a legal RFID tag. And when I tap it and it turns green, then I should be able to create a program that are reading this unique tag ID into a programming language like Python, LabVIEW, C#, etc. So let's start with a Python program. I'm using this Tony Python editor. I have created a similar Python program as for the previous RFID reader, but in this case I'm using COM3. Baud rate is 9600, and for this system, for the tags I'm using, it consists of 4 bytes. So I'm just reading 4 bytes from the serial port, and when I'm tapping a tag on top of the reader, I should be able to read this unique tag ID. So then I just create and convert it to a hexadecimal value, and then I just change it to upper cases, and then I just print it on the screen. I sleep for 1 second, and then these loops go into an infinitive loop, and then I can just tap a new tag on top of my device. So let's just start and create this, just run this example. So now I'm putting a tag on top of my device, which you see here. I remove it, I put a new tag on top, and you see I'm able to read this unique tag ID. I remove it, put a new one, and then you see I get a new unique tag ID. Remove it, and finally I put this 4th tag I have on top of the reader, and you see I'm able to read this unique tag ID. So that's basically the Python program. It's very simple. It's about 10 lines of code, and that's all you need in order to read and get this unique tag ID from this RFID reader system. Next, let's take a close look at my LabVIEW example. It's almost identical as the previous example. I'm going to present the tag ID here in this text box. So when I run this program and tap tag on top of the reader, it should be presented here, and then I can stop the program by clicking the stop button. So this is the user interface, and this is the block diagram of our code. So here I open the communication with the serial port, select the proper COM port, COM3 in this case, select 9600 baud rate, data bits is equal to 8, parity none, 1 stop bit, etc. And then when I'm able to read information from the serial port, in this case 4 bytes, so when I read 4 bytes, this turns true, and if I'm not able to read any bytes, it just do nothing. But when I'm able to read 4 bytes, it goes into this case, and then read information from the serial port, do some manipulation here in order to be able to present the RFID tag here in this text box. When I click the stop button, I clear the serial port and close it, and if there are some errors, it's presented here in the bottom. So let's just start this application. So now let's tap a tag on top of the reader, and you see I'm able to read this unique tag ID. Let's remove it and put a new one, and then you see I'm able to read another tag. Let's tap a new tag, and you see I get a new unique ID. And finally, this 4th tag I have, I tap it, and then you see it's able to read this unique tag ID. So that's how you are able to communicate with the USB RFID system using LabVIEW. So finally, let's go through the Visual Studio and C# example. It's almost identical as the previous C# example for the other RFID system. So I created a basic form here, a text box where I'm going to present the RFID tag, a button for initializing the serial port, and a button for reading the tag. And of course, it should be improved by using a while loop, a timer, etc. But let's just take a closer look at the code. So let's double click on this button. So here, when the application starts, it starts to initialize the serial port, in this case COM3 9600 baud rate, parity none, 8 data bits and 1 stop bit. And then in the initialize button I open the serial port and enable this DTR feature, and I just clear this text box, and then I click read tag. It goes into this method. So I just created a byte array here. Read timeout for the serial communication is 1000 milliseconds, and then I read information from the serial port, and then I just convert this byte array to a hexadecimal number, and then I just put the value into this text box. So let's just run this example. So this is my graphical user interface. Let's start initialize the serial port. Now I have a tag ready. I put it on top of the reader and click read tag, and then you see I'm able to read this unique tag ID. This is a very simple program, so I just need to initialize it every time. Of course it should be improved, but it's just a basic program in order to show the basic principles. So now I click initialize once more to clear this one, find a new tag, put it on top and click read tag. Now I'm getting this error, so I just stop it, start it once more, initialize, I tap and find the serial number, I find a new tag, click initialize and read this unique tag. So basically this is a very basic program that has some flaws, but it's a starting point for creating your own program for communicating with this RFID system. So initialize and read tag. Like this. So every time I just click initialize, make sure the LED turns green, then I can click the read tag. That's why I got these error messages earlier, because I was not tapping correctly. So this program needs to be more robust, of course, but it's just a basic program to show the basic principles. So now in each time just click initialize, tap it, make sure that LED is green, and then read tag. Initialize once more, find a new tag, make sure the LED on the reader is green, then click read tag, and then you get this unique tag ID. So basically this is a very basic Visual Studio C# program that are able to communicate with the serial port and present the unique tag ID in your user interface. So that's all. In this tutorial I presented shortly and gave an overview of RFID systems in general. I presented 2 different RFID readers, and also for each of those readers I presented code examples in Python, LabVIEW and in Visual Studio C#. So that's all. So good luck with RFID and creating your own RFID system. Thank you.